In year 2014, Christopher Nolan gave us one more masterpiece, Interstellar. The movie portrays future perspective of Earth. Movie talks about year 2067, where Earth has been hit with disasters, dust storms, resulting in global famines. Human race is on verge of extinction, and to prevent that from happening, scientists are trying to find any possible solution. But there is only one option left, and that is to find another habitable planet like our planet Earth. So, Cooper, the protagonist of the movie, who is a NASA pilot and science engineer, along with his crew, embarks on a journey to find another abode for humanity. Cooper and his crew embarks on Endurance, that is name of his spaceship. They travel through a wormhole to another galaxy. In that galaxy, there are three planets who are revolving around a supermassive black hole, Gargantua. When Cooper visits first planet, that planet is called Aqua Planet as it is mostly covered with water. There, one of their crew members drowned in big tidal wave. The same tide causes the ship engine to be filled with water, forcing Cooper and his crew to wait until it dries out. They return to Endurance in an hour, only to find that 23 years has been passed on board. It basically means each hour spent on Aqua Planet is equal to 23 years on Earth. This happened due to planet's close proximity with Gargantua. This phenomenon is called time dilation. What is this time dilation? Let's leave that topic for some other time. Today we are gonna talk about black hole.
Black holes are some of the most fascinating objects in space. Cosmic leviathans.
Where do they come from? And what happens if you fall into one?
A black hole is a region in space where the force of gravity is so strong, not even light, the fastest known entity in our universe, can escape.
In 1915, physicist Albert Einstein published General Theory of Relativity, which revolutionized the field of physics, astrophysics, along with other fields of science. In General Theory of Relativity, Einstein states that gravity affects light, sound, and nearly every aspect in our universe. When gravity is too strong, it can even bend light itself. To understand this, let's do a visual experiment. Now visualize a space-time graph or mesh. If you place an object with certain mass at its center, what will happen? Yes, it will bend. Now if I replace object with another one which has higher mass and density, what will happen now? It will bend even more. Now imagine an object with infinite mass and density. If I place such an object at center of space-time mesh, what will happen then? The bend will be infinite. In this experiment, bend in the space-time fabric indicates the gravity of that particular object. Bend in space-time is directly proportional to gravity. It means more the bend, greater the gravity. So if the bend is infinite, then the gravity has to be infinite as well, right? And that is exactly what a black hole is. Term black hole was coined in 1967. But its first reference goes as back as 1784, when astronomical pioneer John Michell proposed an idea of a very big body that even light could not escape it. Later on, in 1915, as we all know, Einstein published his General Theory of Relativity, in which he indicates possibility of black hole, but it was only in theory. He himself was not convinced that such an object would exist in reality. Later on, scientists like Carl Schwarzschild, Johannes Droste, and Subramaniam Chandrasekhar worked on equations of general theory of relativity and theoretically proved existence of black hole. It was only in 1964 when NASA scientists observed X-rays being emitted from certain object in space. First image of black hole was captured in 2019 using Event Horizon Telescope. To understand this, we have to take a look at life of a star. There are hundreds and thousands of reactions going on inside a star every second. Those reactions are called nuclear fusion reactions. Star needs fuel for these reactions, and hydrogen present inside it acts as a fuel. During these reactions, star exhibits pressure outwards, which is balanced by gravitational pressure, which is acting in opposite direction, that is inward, creating an equilibrium. Eventually, star runs out of fuel and stop exhibiting outward pressure, which disrupts the equilibrium, allowing gravitational force to apply inward pressure, crushing outer layers of a star so hard that its size decreases dramatically and it becomes so dense, resulting in an explosive event called supernova. After supernova, if star has enough mass, it becomes black hole, and if it doesn't have that enough mass, it becomes a neutron star. There are three types of black hole: primordial, stellar, supermassive. Let's take a look at each one of them one by one. Primordial black hole. Scientists believe that it is as small as an atom, but has mass greater than that of mountain. It is only hypothesis though, as we have not discovered any primordial black hole. Stellar black hole. These are most common type of black hole, with mass that of 20 suns. There might be dozens of them in our Milky Way galaxy itself. Supermassive black hole. It has mass of about 1 million suns. Scientists believe that there is one supermassive black hole at center of each galaxy. Our own Milky Way galaxy has one at its center, called Sagittarius A+. Sagittarius has mass of about 4 million suns and diameter equals to that of Sun. Scientists believe that supermassive black holes were formed at the same time when galaxies were being created. Except these three types of black hole, scientists believe that there is a possibility of fourth type of black hole. It is called as intermediate black hole, which would have size in between stellar and supermassive black hole. Scientists have not discovered any intermediate black hole till date. Now, let's get back to the movie scene from Interstellar. Here you can see Cooper's spaceship is approaching a circular area made up of light. It is called accretion disk. When black hole engulfs any star, that star gets disintegrated. It gets torn into bits and pieces. Emitting lots of gases, those gaseous particles make disk-like structure around black hole. That is accretion disk. Accretion disk looks like this due to optical illusion, which is caused by extremely strong gravity. As gravity is very strong, it can bend light itself, resulting in optical illusion. When observed from top view, black hole will look like this, circular. Now, let's get further inside of black hole. As Cooper gets inside of black hole, he approaches event horizon, which is also called as point of no return. Yes, as the name itself suggests, this is the point beyond which nothing can escape. Nothing. Here gravity is so strong, the stars and other celestial objects get vanished. Here, escape velocity is equal to the speed of light. To understand this, we have to first understand what is escape velocity. Escape velocity is the minimum velocity required for a body to escape planet's gravitational attraction. Escape velocity of Earth is 11,186 meter per second. That is 11.2 km per second. Every spaceship satellite must have a velocity of 11.2 km per second in order to escape Earth's gravitational pull. Escape velocity of black hole is equal to speed of light, which is 3 lakh km per second. As we all know, it is impossible for any object with mass to travel at speed of light. The fastest spacecraft humans ever created is Parker's Solar Probe. It has fastest speed of 163 km per second. It is only 0.054% of speed of light. Basically, we have no technology that can make us travel at a speed of light. So it is impossible for us to escape from black hole's gravitational field. Now, let's get further deep inside black hole. Now here comes the photon sphere. Here light is spread evenly and revolve around circles. One could see back of his own head as light here travels in circle. Beyond this, we don't know what exists beyond this. In theory, scientists conclude that it is the point where all the mass is concentrated at single point called as singularity. Some suggest that this is pathway to travel to another dimension or universe. As we saw in Interstellar, when Cooper's ship gets wrecked and he falls into black hole, he arrives at a place which has fifth dimension, a tesseract. Here we can see time as a physical quantity, but it is all part of a fiction as we have no way to confirm that. As of now, we only have this image of black hole. Beyond this, we don't have any evidence to prove any theory. The black hole nearest to Earth is called unicorn. It is 1500 light years away from Earth. It would take us 7 million years to reach it with our current fastest spacecraft. As of now, there is no way for us to reach there in this lifetime. And even if we somehow manage to reach it, as soon as we get near the event horizon, our body will most likely turn into noodle-like structure, called as spaghettification. Our body will be torn into bits and pieces within milliseconds and will be distributed equally across event horizon. Sounds horrifying, right? No, Sun does not have enough mass to turn into a black hole. The Sun would need to be 20 times more massive to end its life as a black hole. Remember the star cycle we discussed before? Our Sun will eventually run out of fuel and all the nuclear fusion reactions going on inside it will end, which will disrupt the equilibrium. Then inward pressure exhibited by gravity will become greater than outward pressure. Due to this imbalance, Sun will be crushed and its size will decrease and it will become a white dwarf. Over a long period of time, that white dwarf will cool down. It won't have any heat energy or light to emit anymore. It will turn into black dwarf. Most of the stars that we see in our night sky will share the same fate. If black hole is black, then how scientists were able to detect it? As we have seen before, anything that comes in contact with black hole will be torn apart. When a star comes in contact with black hole disintegrates star into bits and pieces. In this process, particles near black hole gets heated up to millions of degrees and emit radio waves and X-rays. We humans have instruments to detect those X-rays. So whenever we detect X-rays being emitted from black region in space, there is a possibility that could be a black hole. As of now, we have no means to reach a black hole, nearest one being 1500 light years away. It would take us 7 million years to reach it with our current technology. But let's assume we somehow manage to do it. Upon arriving at event horizon, our body will turn into noodle-like structure. Our body will get distributed equally around event horizon, and all this will happen in milliseconds. A person standing outside won't know what happened to us, as no information can be transmitted through black hole. Black hole closest to our planet Earth is 1500 light years away. We do not have any actual danger from it. All the stars near Earth, including our Sun, will turn into a white dwarf at the end of their life cycle. So as of now, we have no immediate danger from any black hole. I hope you liked the video. For more content like this, do subscribe, like and share. Thank you.